Guys, good morning. Thanks for joining in so early in the morning. Let's get started. Give me a moment. Let me share my screen. Can everyone see my screen?
Yes, can see.
All right. So let's get started. First ever virtual Global Azure Bootcamp. Super excited to do it virtually this time around. So my topic is going to be on Personalizer. This is a new product from Microsoft, and it's based out of this whole idea of reinforcement learning. Now, as you kind of think about this, right, reinforcement learning or the idea of this whole contextual bandit is not very new. A lot of companies have been using this in the past, and a lot of its foundation coming from a lot of biological influences. So if you think about, most of us are Asians, the way we were taught up to grow is that, hey, you study well, you'll get good marks, you'll get good salary, good bonuses. So you are kind of reinforcing some of the good behaviors. If you don't do well, then you're not going to get that promotion, you're not going to get that grade, you're not going to do some of these things, right? So the same concepts go in for the idea of reinforcement learning, and a lot of companies do that, right? So if you think about Netflix, I'm sure everybody has a Netflix subscription. If you don't, the way they end up doing it is the artwork that you see that comes up is dynamic. It keeps changing. You would have seen that it keeps changing over a period of time. The whole idea for them is to enable you to find something interesting, something that catches your eye, and for you to at least try that series or movie out before you decide to go do something else, right? So they keep playing around with this artwork, and this is a concept that they used for using reinforcement learning. On the other hand, a company like Microsoft, they use it very, very extensively, right? If you have been on Xbox, the recommendations that you get, the preferences that you get are some of the options that are powered by Personalizer. And this is something that they had done during their launch video as well. They said that, hey, close to about 40% of their hits increment or user engagement really came in because of Personalizer, right? Because it was able to understand the user needs fairly quickly, and it got them up and running. We at Property Guru, where I work, my current employer, do also extensively use reinforcement learning. We use it for a lot of activities internally, and something that's becoming a common use. So in this session, what we are going to learn is what is reinforcement learning. We will take a look at maybe a couple of examples of how it really works, kind of get to understand some of the basic concepts in reinforcement learning, and then we'll jump onto the demo. So everything that you essentially learned will kind of get used for our demo today. Our demo today is going to be on picking up your food choices depending on what your preferences are. So we'll kind of work through that. All right, so let's get running, right? So this whole idea of Personalizer, there are two key words that you have to think about. What it's called contextual bandits. So we'll understand, what is a bandit and what does contextual mean in the world of bandits, right? So think of the bandits as the dacoits or something. So it's a similar idea that comes in there. So let's spend some time to understand what it means. All right. So if you have done traditional programming, right, your brain essentially is the algorithm, right? You will give it an input. It will go through some logic that you have trained the algorithm for, and it will generate some output for you, right? If you think about the world of machine learning, the way it's going to work is you will have an input, right? The algorithm will look at the output and figure out, what parameter it needs to tune to generate the output, right? But in the world of reinforcement learning, this is completely different. So you are going to make an observation, right? The agent is going to kind of look at that observation and determine an action, right? That action is going to act in the real world, right? It could be as simple as whether you like the choice or not, whether you are clicking or not, and whether or not what happens in that real world, you will get a reward. And this is not a guarantee, right? You may or may not get a reward, and that's something that we have to think through. So if you do get a reward, the agent is going to kind of reinforce the part that the decision that it took or the action that it took based on the observation was the right one, and it adjusts its parameters and goes out from there, right? Now, this loop keeps on repeating itself, and that's something that, it becomes a continuous process in itself, right? So the world might change. That's why the observation might also change, and that may change the behavior of the agent itself. Now, agent in your world, you can think about as a model, a machine learning model or an algorithm. The idea remains the same, right? But because the agent is making a decision for you, that's why it's there. Now, in a lot of these scenarios, right, when you are observing the world, not all the states are fully observable, which means that you cannot observe everything besides maybe a small portion of it. So let's take an example that we are going to work out later in the session, where I am trying to figure out what your food choices are. Now, your food choices can depend on, whether you are in for something sweet, whether you're in for something savory, or, you have a completely different choice in there, right? So I don't know what your mood is going to be, right? I don't know what your religious preferences are. I don't know what other limitations that you have, right? So my world of observation becomes fairly small and fairly limited. And that's why, we say that the state may not be fully observable, and the agent has to guess those things before it decides to take an action. So similarly, if you think about your machine learning models, right? So not all your features are going to be useful. There are some features for which you cannot collect the data. The same idea applies here as well, that, this state or these observations, all the attributes related to that actions or observations are not something that you can observe and work on. So that becomes a challenge for reinforcement learning, right? Now, there are a few types of reinforcement learning. Right? You would have seen a self-driving car. You would have seen, the chess algorithms in there, or the AlphaGo that was famous recently. In all of those examples that you saw, the rewards are delayed, right? So you don't get to see the result of your actions until the game is over, or until you have won or lost the games as well. So in this case, your rewards are delayed. So in the world of machine learning, you say that if your rewards are not delayed, it becomes a bandit problem, right? So that's a distinguishing criteria in there. So for example, in your website, right, I show you a recommendation for games, or for, in our case, properties, or for Netflix, it becomes, different sets of movies with different artworks, right? Whether the user clicked or not, the decision is almost instantaneous. So the algorithm immediately knows that, hey, whether you liked it or not, or whether I should make a decision on it or not. So that's where we say that, if the rewards are not delayed, it becomes a bandit problem. Now, let's go into a detail of it a little bit more, right? So how does a bandit play into this scenario, right? So let's say you are in a casino, and this is a very, very typical example that everybody will use in for reinforcement learning algorithm. So let's say you are in a casino, right? So the casino becomes one-arm bandit, because, in a slot machine, you can pull an arm and, it will, the wheels will turn, and then whatever shows up on the wheel, essentially you will get that, right? So let's make our job simple, right? We'll say that either you win or you lose, right? There is no gray line between that, or how many lines you have finished, none of those, right? So we'll say that the yield is going to be 0 or 1, but you don't know what the state of the machine is, right? Is it close to giving you a lot of money, or is it close to the fact that, it has given out a lot of money, and, next few turns are going to be giving you 0, right? So you don't know what the payoff strategy is. So when you kind of working through these three slot machines, how would you determine which arm that should pull that will give you the maximum rewards, or which will make you win a lot of $1 over a period of time, right? Or in other words, or in the world of multi-arm bandit, if you think about it, it says that you have to minimize your regret, right? So your regret in this thing is going to be losing uh, that money that you paid for playing that game. So how would you make sure that you are kind of reducing that regret over a period of time? Now, so the way, again, you kind of think about this, right? So there are a few observations that you can make, right? So in this state, right, of the three machines, right, you ended up picking one arm. Let's say, let's say our slot machines were A, B, C. You pulled an arm for one, right? So here we assume that the state changes. Now you don't know what happened to the other two machines. Had you put your money there, you don't know what would have happened at that point in time, right? So this becomes a partial information problem. So you cannot observe everything and there, right? Kind of going back to the concept that I explained in here, that you don't know, had you put your $1 in there, what would have happened, right? Would you have won $1 million or not? So you have to, kind of make a model, right? Similar to what you do in machine learning or the way you develop your algorithm itself. You have to create some sort of an approximation of how your engine works, right? Or how these slot machines works, so that you are able to understand some concept and figure out how you are going to maximize your reward over a period of time. So over here, you want to kind of build an approximate approach where it's going to tell you whether you're going to win or not, right? And lastly, at some point, right, even when I kind of explained the first observation, you were like, yeah, why can't I then just go and play with the remaining two machines as well to just get an idea of how that's going to work? And that's something that we do in reinforcement learning as well. I'm going to go out and do it. Like, I'm going to go out and explore all these arms before I make a decisions to determine which is the arm that's going to give me the maximum reward. And in our case of slot machine, which arm of that slot machine will I be picking to get a better outcome for myself? I'd just like to pause for a moment and see if there are any questions in here. Hey, sorry, you're breaking off quite a bit. All right. If there are none, let's move on. Right. So as much as we would like to do exploration itself, at some point we are going to figure out, which is the best arm that we want to exploit. Right. So you are going to, of course, do your exploration, figure out what options that are available to you, and then you are going to pick your choice that you think is giving you the better arm, better reward. And that's the arm that you're going to pick as well. So, so the balance is between, exploration and exploitation. Exploration is where you are going to acquire knowledge. You're going to go out and look at, what are the choices that are available to you. And then your exploitation is where you are going to, once you have determined which is the arm that you're going to pull, you are going to figure out that, okay, I'm going to maximize my reward, right? So if you do a lot of exploration, you're missing out on exploitation. If you do end up doing a lot of exploitation, then you are also missing out on, hey, the preferences have changed, or there is a new option that's available that's not there to you. So this is a balancing act that you have to maintain in the world of reinforcement learning, right? So how do we solve it? Right. So there are different algorithms that are in there. And, I think this time is too short for us to kind of go over the complete logic. But, I'll kind of bring home a couple of examples so that you can kind of think through of how they work. All right. So let's do something naive. right? This is something that's true for when we do a lot of A/B testing. So in A/B testing, you'll have two choices, A, B, or even a third choice, A, B, C. So over here, we have our three choices, ARM1, ARM2, ARM3. So for each of them, I'm going to do about 100 trials, right? So I'm going to spend pulling arms for each of these things for a total of 300 times. And then I find out that my ARM1 gave me only 2 wins, my ARM2 gave me 21 wins, and my ARM3 gave me 7 wins, right? And then I'll determine that, hey, my ARM2 is the best. Now, this is naive because, I never exploited any of the knowledge that was coming in there. Instead, I relied on the fact that, hey, I'm going to kind of give equal chances to each one and let it win. Now, this is, of course, is not, super useful. So what we do in next is, we are going to kind of do another, which is going to be a greedy approach in itself, right? So we will keep pulling it again, similar logic in here, but my greedy approach is going to be, I'm going to pick the one with the greatest number of chances, right? But if I kind of change it slightly, right? So, after a point in time when I've done my exploration, right, I will say that, I'll keep a probability of 10%, which means that out of the 100 pulls that I do, for 10%, I'll go out and try other arms as well, right? And as and when I get to see more and more improvements, I will start to do that exploitation. So I'll pick a value, in my case, it's an epsilon, which I said 0.1, which means 10% of the time I'm going to go out and do the exploration, right? So when I have no data, I'm going to kind of do an equal exploration. And once I figure out that, hey, this arm is doing pretty well, I'm going to start exploiting that. And then 90% of the time, 1 minus epsilon, I'm going to figure out that I'm going to pick the arm that is giving me maximum rewards. And 10% of the time, I'm going to do the exploration. Now, this keeps on going over and over and over. And it, over time, you will do it, right? So over here, your maximum regret or the maximum times that you will end up losing is determined by saying that it's limited to 10%, right? So that's how you do it. Now, there are a lot more algorithms that are in there which exploit a lot of statistical properties of the data itself. And that's something that we can continue to do. All right. So what's going to happen is that, let's just do a comparison of the two logics that we run, right? So in the first one, we picked, n total of 300. And then, my epoch greedy was the fact that where I said that, hey, if my best arm is getting selected, let's say, 200 times. So, basically it's going to pick 15% of the time it's going to pick the choice, right? In my epsilon greedy, it's, we kind of explained that, hey, it's my regret is limited to, 10%. So it's only 10% of the time that it's going to go out and explore suboptimal choices. You don't know whether they are suboptimal. So it's going to go out and try other things. And it might so happen that something else during that exploration becomes much, much more better. And over a period of time, you will find that the other arms do get picked as well. So, it's going to explore all these choices at the moment, right? There's this whole idea of Thompson sampling. And, let's just kind of quickly take a look of, how it's a small modification over epsilon greedy. So in here, let's say again, we have 3 arms and, I'll pick a random choice of 10%. Now I will, I can do this a determined number of times. Let's say, for each arm, I'm going to try 20 times. So that kind of gets me the rewards. And then I'll choose the arm with the highest values, right? So now from the 20 tries that I've done for each arm, I will pick the one that gives me the highest value, right? And then based on it, I will update the distribution, the underlying distribution that it has. And it's going to keep doing that over and over a period of time where it finally determines how it did. So let's take a very, very quick example of how that's going to work, right? So I'm assuming you guys know what a uniform distribution is, which means that there's an equal chance that any number will get picked, right? So a very typical real life example is rolling a dice, a single dice, right? So if you roll a dice, there's an equal chance that it will pick a number from 1 to 6 with equal probability, right? So the same idea is there. And let's say I have my 2 arms that are sitting in there. Each one either gives me a reward of 0 or 1, and we kind of assume that the function is going to be continuous, right? So I just kind of say that, all right, both of these distributions are similar. I'm not making any guesses at this point of which arm will do best. So I, like we said, right, I'm going to sample both of them initially, right? And, my first choice for the black arm came in somewhere here, and my blue arm actually gave me a better reward, and it became here, right? So what I'm going to do is I'm going to slightly change the distribution. So my black arm, of course, didn't do a good job. So I'm going to say that, okay, my 1 did a better job. So I'm going to slightly shift it towards the right, towards the value of 1. Then I go and do the sampling again. And then I find that, again, blue did well, better than black. And then I move my distribution slightly to the right. Now I keep doing that over a period of time. And my distribution is going to look something like this, right? Where my blue distribution is shifting to the right. My black distribution is essentially shifting to the left. Now I keep doing that over and over and over again. And it might so happen that, my numbers have swapped, right? It actually turns out that my black was a better option. It's just that, while I was working through it, it became a bad choice. Now, when you kind of keep doing this over a period of time, it will help you find out globally, right, with the choices that you have, which is the best arm that will maximize my rewards over a period of time, or will maximize the objective that I'm going to work on over a period of time, right? One thing to do note is that, although it says that it's going to pick the best arm, it's not necessarily true, right? So based on your distribution, it might so happen that, it's not picking up the best one, and something that you might have to kind of live with the limitations of these algorithms as well. So the same ideas go into that reinforcement learning. So you have to sample it for a few times, let it play around, and then once it has enough data associated with that, then you go and keep updating your probabilities for each of your choices. And then once you have it, it will start working and giving you better choices for that, right? So in the context, so we kind of understood the context bandit itself, where, I was only worried about the reward itself, right? I never observed and say that, what was the environment at that point in time, right? So if you kind of get an environment in there where you give a context vector. So let's say, when I was playing this, this slot machine, in that one, I didn't do any observation. Hey, is the machine new? Has it been loaded recently? How many people have done? I have not done any of those things. Now, if you start to figure that out, or if you start to collect the data, and then you pass that observations or that context to the algorithm itself, it will then figure out that in the given context, what is the highest reward that it needs to get, right? So that's something that you can kind of build up and work through that. And this is the idea of contextual bandits, right? So you know what is the context of the environment, and then you make a recommendation of what reward or what arm it needs to pick to kind of work that out. So, there are a lot of use cases for personalizers, right? You could do an A/B testing, right? You know what your users' choices are, what they have seen in the past. In the case of Netflix, you can get much smarter with that knowledge that you have collected and do, instead of doing A/B testing that you did, that we observed before, that, hey, do 100 tests, 100 tests, 100 tests, and then determine which one is better. You can, apply the ideas of contextual bandits and, improve your A/B testing to be done better, right? We kind of saw that for content recommendation. You can do the same idea for ranking products as well, right? So how are you going to kind of rank your products, that's also a concept that you can kind of build in. Now, let's spend some time for a demo. I'll just pause for a couple of minutes to see if there are any pending questions or doubts anybody has. I'll just open up the chat window for a moment. If you do, yes.
One question.
Sure.
Why is contextual bandit over full art techniques like current? Do you
Hey, there's a lot of noise background for you. Can you repeat?
Okay. For personalization, 1 minute.
So I have a question in here.
As it is, you can see in your chat window.
Yeah, okay. So one question is there on the chat window. It's, why contextual bandit is chosen over full reinforcement learning techniques like deep reinforcement learning. Do you think sequential decision has potential to understand the context of the whole chat instead of the current question in there? Yes, so that's where the context or contextual bandits come into play. Deep reinforcement learning are also a variety of stuff in there. So, again, there are a lot of these ideas in there, and, it's an extremely broad topic for this. The idea of so the way we are looking at it is the contextual bandit. So, it will immediately look at, what you are talking and kind of make a decision at that point in time, right? So for longer context where you are looking at chat, of course, you can use the personalizer for this option. But it just makes it harder to kind of manage the context over a period of time, right? So the idea that we are working through a personalizer is, hey, I gave you a choice. Did you pick the choice or not, right? You can make it binary where your rewards are 0 to 1, or you can keep it continuous where you are going to say that he picked it after a while, so maybe he pondered, so maybe it was not the first choice, and you can kind of give it a smaller reward over a period of time. Or let's say you come back to this choice later on, you might give a lower reward than something that you have seen before. So that's where the differences come in as compared to any other techniques that you have seen. Any other questions on this so far? All right. If there are none, let me then let's spend some few minutes for the demo itself. Let me go back to sharing my screen. All right. So what I've done is, I'm going to kind of do a quick choice for me, and I'm going to help me determine, what are my food preferences over here. And, I've given it some choices, right? So I said, I like pasta. And for each pasta, I've given it, what the attributes are. So I've given it an attribute of taste and said that it's salty, spice level, it's medium, nutrition level, it's 5, and cuisine is Italian, right? So I've given this becomes my one action. My second action is ice cream, which has an attribute of taste as sweet. I have a juice, which has an attribute of taste sweet. And I also added a new attribute in here, which is saying the drink is equal to true, right? And then you would observe that for a lot of these actions I have, my feature sets is completely different, right? So over here I had cuisine, but none of my values other than that has cuisine. For most of them, I do have nutrition level, right? I have a factor of taste. And then for some of them, I didn't even pass any values for spice level, right? So I can, the idea in personalizer is you can add these features as you keep finding more knowledge. And that's something that you can improve over a period of time, right? So I gave 4 choices for it, saying that, hey, I have pasta, I have ice cream, I have juice, and I have salad, right? So these are the 4 choices between which the algorithm needs to kind of pick in there, right? The next one that it's going to do is it's going to figure out what my preferences are. Do I prefer salty or do I prefer sweet? Right. And then I said, what is the time of the day? So I said, is it morning, afternoon, evening, or night? Right. So I've kind of gone through these choices, and I'm going to figure out like, hey, how many times should I be kind of running this through. So let me run this as a simple example. So it's asking me, hey, what type of food you prefer. So I say I prefer sweet food. What time of day it is? Let's say it's evening. And then it says, my algorithm, I kind of ran it a few times, and it said that, hey, my algorithm or the personalizer thinks that, I think I would like to have an ice cream. And you can see that, right? It has adapted its probabilities to say that, hey, ice cream is a better choice. And I could say yes or no, and that would kind of go and affect the decisions for its logic as well. So similar to, what we did for the idea of Thompson sampling, that we kept on changing the distributions, the underlying distributions, it will go and figure this out, right? So over here, it's just saying that I showed you ice cream, do you like it or not, right? It's not going and saying that what would you have preferred. So this is where it becomes a slightly different exercise. And it goes back to the observation that we had earlier in the presentation, that I don't know what my choices would have, right? So the algorithm doesn't come back and ask me that, hey, what would you have preferred, right? Because you don't know the state at that point in time, right? So I'm going to say, yes, I liked it. And that becomes, now it's going to go back and update the logic as well. Now let's go through this logic again, where I'm going to say that, okay, I like to eat something sweet. And it's, let's say it's after evening again. And then it again tells me that, is this there? So now I say, no, it's not. So it's going to go back and update its probabilities to help me figure out, what I am interested in at what point in time. Right now, because it's stuck on that point that, hey, I keep loving ice cream, and it doesn't understand that, hey, I could have a different choice. So it's not updated that probabilities. And this is something that you have to kind of let the algorithm work through for it to enable a few choices, right? So you will have to let the algorithm run a few, hundreds of thousands of times, depending on how big of your feature set is, for it to figure out what logic is there. It's the same logic that you would go in a machine learning world as well, where you would have to capture good amount of data for it to make a better model for it too. So now, instead of running through this, let's just run through all these choices. So I've done the same. I have the time of the day preferences. I also have the taste preferences, and I also have my 3 choices in here. But instead of doing it interactive, what we are going to do is kind of do it in a dynamic fashion, where my rewards are kind of pre-coded, right? So this is something that the algorithm doesn't get to see, but I have kind of, to make it easier to run it a few hundreds of times, I have allowed for this. So now I'm saying that in the morning, if my choice is sweet, I would prefer a juice. And the same thing goes for afternoon and evening, right? So my choices, if I feel like having something sweet, I'll have a juice. In the morning, if I feel to have something salty, I'll have a salad. In the afternoon, it's going to be pasta. In the evening and night, I'm trying to be healthy, so I'm going to prefer eating salad as well. Right, so that's something that I can keep doing and saying that, okay, this reward function that I have is essentially going to, this reward function that I have is going to get my time of the day and taste preferences, which was randomly picked. And it's going to assign a reward associated with that, right? So if my choice was correct, then it will give me a reward of 1. If it's incorrect, it's going to give me a choice of 0, right? So that's how we kind of work that out. So I've just said that, I've loaded the JSON and said that, hey, if my action is correct, then I'm going to pick 1. If not, then I'm going to pick 0. So that's all I have to do. And what I'm going to do is run it a few hundreds of times and see over a period of time, how long does it take to kind of do it, right? So it said salty evening, it's still picking juice for me. And then at some point, it's making correct choice. At some points, it's making incorrect choices, right? So now this will keep on happening over and over. But one thing that you will observe that, right now, the probabilities are not being changed, right? And this is a factor that you can control from your front end Azure personalizer system as well. So when you come to your configurations, right? So in your configurations, you are saying, how frequently, let me just zoom in a bit. So over here in my model update frequency, you are saying that, how frequently the model should be updated, right? So over here, I'm saying that, update the model every 1 minute. And this is something that you have to you have to set it up. Now, how do you determine that? That's something that is dependent on, how quickly you are able to collect the data as well. So, I've set it for 1 minute so that every 1 minute, we will be able to kind of update our model, which means that for each of these models, it's going to update the frequency as well. Now, I can also determine, how much exploration it needs to do, right? So if the user patterns are changing or my preferences are changing, I can kind of determine how much time I can do exploration as well. So this is something that I can, figure out and say that, hey, I'm going to do 5% exploitation, or I'm going to do 25% exploration, and that will determine how many times it will go and ask choices, even though it knows that the correct choice is something else, right? And then this is something that you can kind of work with, where when algorithm is given a choice, how long should it wait before saying that my default reward is going to be something else, right? So if my website is interactive, where I have shown a choice and nobody has picked anything, then how long should it wait before it says that the reward is going to be 0, right? So that's something that you have to kind of think and work through as you kind of set it up, right? And there is no wrong or right answer. This is dependent on what model you are kind of going to work with. Now that's something that I keep doing this over and over, and then after a point, it's going to kind of figure out that, hey, whether my choices are correct or whether my choices are going to be incorrect. So now it's starting to make some good choices for me, where if it's sweet in the morning, it says I want to have juice, which is the correct choice. The same sweet in the morning, I want to have juice. So it starts to determine a lot of these values, and it's going to keep going back and forth to do that. Similarly, it has some model settings in there, where I've picked a model and I've kind of worked through a choice, but there are a lot of different settings that are available internally, right? So I have created an evaluation model, and I've said that, hey, go and figure out, like, hey, are there any learning models that were better? And if the answer becomes yes, and then I can see that, hey, these are all the different types of algorithms that are sitting in there. And I do find that, this Hyper2 logic seems to give me a better reward overall, right? And I could just hit apply, and it will retrain the model using this hyper logic that I have, right? It's not going to pick my choice over here, which is supposedly my baseline, right? So my Hyper2 essentially does give me a better performance, and I could do that, right? And that's something that I can evaluate over a period of time as well. Then the next thing that you can do is, we kind of said that, hey, there were a lot of these features that were there. Now, of all these features, which of the features were really important, right? So in the context, we said that taste preference is there, and most of the time it's salty, and then the day after time is afternoon. Ice cream, juice, pasta are my given choices at there, right? So it hasn't figured out that, hey, salad is there. Salad is my preferred choice. So it's not picking that up yet. But if I let it play around for a longer period of time, it's going to end up picking that for me going in. So just like your typical machine learning models, you will have to kind of work through the logic through itself. It's going to make a lot of mistakes initially, but after after a few iterations, it's going to get smarter and start making very, very intelligent predictions for this. So that was all that I had for personalizers. I'll just open up the floor for any questions that you might have. Feel free to ask before I pass it to the next speaker.
I see they have two questions.
Sure. It's on the chat. All right. So is there a way to standardize environment handler for RL? So OpenAI Gym is much different, right? So over there you're learning a different type of algorithm itself. So over there, when you end up playing games or something, it's going to maximize your reward over a period of time. Similar logic to what you are seeing over here, but this is not meant for OpenAI Gym, right? That's a different domain in itself. And there's one more question from Geeta. How can we enable automatic machine learning from archive data? I just showed you on, let me share my screen again. So in my evaluation summary, right, when I picked a new, so these are the algorithms that are sitting in there, right? So one of them is online and random. So whatever is going on is going to be there. So now when I go and pick, like saying that, okay, I'm going to pick Hyper as my next choice, all I have to do is pick that algorithm and hit apply. And it's going to retrain that algorithm with the new learnings or the new model that you have selected. And it's going to do that automatically for you and swap over to the better model, right? So you don't have to manually go out and change things or having to retrain your model itself, right? So that's something that the model can learn by itself, and it's a feature in there. One thing that you have to do to keep in mind is as you work through the personalizer itself is if you're doing multiple experiments, right, make sure you create a personalizer for each of your experiment. Don't use the same endpoint for all your experiments, right? So if you're doing one experiment, let's say for recommendation, pick one, right? Don't mix it with the other experiments that you are trying to do, right? That will confuse the algorithm that's sitting in there, and it will start to give you incorrect results, right? So one experiment, one endpoint, right? Don't mix and match multiple things in here.
Yeah, as an illustration to it, so when you're making it learn, applying the logic, will the features be refreshed, scratched, or it will be on top of the already built features?
So you can start off with the known features that you know at that point in time. You are certainly free to add new features as you start to find more attributes, maybe about the users or maybe about the choices, or in our code, we had an rankable action. So once you start finding more, you can certainly add those attributes in. And just like you would see in a typical machine learning model, it's going to figure out what features are contributing for it to make a better decision. And it will do that on its own, right? You won't have to kind of set it up and say that pick these ones for your session, for your experiment. Does that answer your question?
Yeah, thanks.
Okay. There's one more. Does the personalizer support warm start using example? Not in this. The warm start is as long as you have entered data into your personalizer endpoint, that is considered doing that. There is an idea of doing offline evaluations in here, but that also assumes that you have collected probabilities for each of your decisions. And usually, most of the times people don't collect that, right? So, but if you have, then you can certainly do an offline evaluation to let the model run on its own, which is an example that I showed you. But there is no way where I have an offline data. I can certainly pass those things to the model, but you won't know, what settings were there at that point in time. Any other questions? All right. If there are none,